Hi guys, welcome to the Pepcoding. In this video, we are going to solve our new question called Meeting Rooms 2. So in the previous question, we have done Meeting Rooms 1, in which we have to return true or false for n number of meetings a man can take all the meetings or not. If the man can take all the meetings, we need to return the true, and else we need to return the false. That was the previous question. So in this question, we have given the same n number of meetings having starting and the ending time, and we need to return in this question, we need to return the minimum number of meeting rooms are required for all the meetings to be done. Here we need to figure out how many minimum number of meeting rooms are required to schedule all the meetings. This means all the meetings can be done in how many minimum number of rooms. So let's see this by the given example, sample input and the output. So here this 5 shows the number of meetings. This is the number of meets and is equal to 5, and the meetings are these, where st and et, that is starting time and the ending time of the meetings, are 1 to 3. This next meeting is 8 to 10, next meeting is 7 to 8, next meeting is 9 to 15, and then the last meeting is from 2 to 6. We need to figure out the minimum number of rooms to schedule all the meetings, to schedule all these meetings. Now here if we see all the meetings, here one meeting start from 1 to 3, the next meeting start from 8 to 10, after 3 it start from 10, and again just by ending this meet from 10 8 to 10, the next meet starts from 7. Here the meeting is from 9 to 15, and the next meet start from 2 to 6. So this means in this in the input we have the inputs not in structure. So the structure, we need to make a structure of this to solve this question, where the structure will be according to the starting time of the meeting, so that we can know, we will know that which meeting will start the next, which meeting will be the next meeting as soon as the possible. Like this, if we see here 1 to 3, the next meet can be start from 2 to 6. Or if we see here the first meet, if this is the first meet 9 to 8, the next meet will be start from 8 to 10, so that we can assign the meetings in the same room. Else we need to check every time all the meets, the next smallest meet is starting. So we need to give a structure to this input. So for making this structure, we need to sort the array according to the start time, so after sorting it, our start time and end time will be, this is the first meet from 1 to 3, the next meet after this will be 2 to 6, so this will be 2 to 6. Now the next meet is 7 to 8, the next meet is 8 to 10, and the last meet is 9 to 15. Now we have a structured input. Now we do know which meeting start first and which meeting is start at the last. From the 1 to 15, we do know all the meets in a structured way according to the start time. So we will use this structure to solve the question. Now let's see. Now we have first meet 2 to 6. If we visualize this, we can easily check the minimum number of rooms are required. So here for the first meet we need one room, so I am making a room 1 for this meet 1 to 3. So this will be 1 to 3. Now this meet is scheduled in room 1. Now the next meet is from 2 to 6. So this 2 to 6 having the two choices. Either it can scheduled in a previous existing room, any existing room, or it can make a new room as room 2. So what is the condition to check that is it can be scheduled in existing room or it should make a new room? For the condition, we check the existing rooms having the ending time, that is 3. Here the existing room is 3. Existing room is room 1 and the ending time is 3. And the next meet is start from 2. So this means one meeting start from 1 to 3, another one is from 2 to 6. So at one time in room, at one time there is one meeting can be scheduled. So for this 2 to 6, there will be a overlap here. So for this 2 to 6, we need another room. So here we will assign room 2 for 2 to 6. 2 to 6 meet. This is for second, this is for first. Now the next meet is 7 to 8. So this 7 to 8 meet have again have two choices. Either it can scheduled in existing, or it can make a new room. If we make new room, we need minimum number of rooms. If we make for each meetings new room, that will be the maximum number of rooms for all the meets. So this means we will check either of these two rooms, this meet can be scheduled or not. So here in room 2, in room 1, the meeting ending at 3. In room 2, the meeting ending at 6. So here we can see the new meeting start from 7. So this 7 to 8 can be scheduled in any room of these, either in room 1, either in room 2, because one is ending at 3, another one is ending at 6. So before starting to the next meet, all the meetings will be in both room, the meetings will be done. So this means we can either choose room 1 or room 2. It is up to us. So here I am choosing it in room 1. I am scheduling it in room 1. So this is for room 1. Now next meet is 8 to 10. So again we will check for the existing room having, or it can make a new room. There are two choices of each meet. So here the room 1 ending time is 8. The room 2 is ending time is 6. And the next meeting start from 8. So either of one of these room it can schedule. So here this time I am scheduling it in room 2. Making it in room 2. 8 to 10. This is for room 2. Now the next meet is from 9 to 15. Again it will check for the previous existing rooms. Ending time is 8. Another one is ending time at 10. So here in this case, the 9 is starting. It is the starting time, and in the room 2 the ending time is 10. This means this 9 to 15 cannot be scheduled in room 2 because there is a meeting going from 8 to 10. So this time it will check for room 1. Here room 1 is ending at 8 and the next meeting start from 9. So this time it is going to be scheduled in room 1. So 9 to 15. Here we can see all the meets are scheduled in only minimum 2 rooms. There are only 2 rooms used, only 2 rooms required for all the meetings to be scheduled. So our answer will be 2. So this is the observation of the question and the solution. How can we solve it? So this is just a overview of solving. How will we code it? First we need to sort the inputs according to the starting time. Now let's see again. We have starting time. Let's sort this. Starting time, ending time. Sort 1 3 2 6 7 8 8 10 9 15. Now for the first meet. For the first meet, we need a room. Room 1 from 1 to 3. Now for the second room. For the second meet. For the second meet, it is starting from 2 to 6. It is from 2 to 6. So we need to check for the existing rooms. Which room? Let's say there is one more room which start from 1 and go till 2. There is a meeting scheduled from 1 to 2, and there is another room which is scheduled from 1 to 3. So for this 2 to 6, it have two choices, either it can come with existing room, it can schedule in existing room, or can make another room. So for this if we just check for the previous one, here 3 is the ending time and the new meet start from 2 to 6. If it just check for the previous one, it will make a new room for it. But there is one more room available. If there is also a meet from 1 to 2, there is one more room available. So this means it can be scheduled. Here the ending time is 2 and this starting time is 2. So it can be scheduled in existing room from 2 to 6. From 2 to 6. No need to make room 3 for this, because we have existing one. So how will we check? That we need a existing room, we need a new room, or we can use the existing room? So for that we need to store the ending time of all the meetings in the rooms, so that we will know that in which room which room is going to be free minimum time. So here we have only one room and it is ending at 3. So here I am going to use a priority queue, min heap type priority queue. In this we will add the ending time of the meet of the rooms. For first room, the ending time is 3. We are adding 3. So here 3 will be at the peak of the priority queue. This is min heap priority queue. Now it will check for the second meet, which is start from 2 till 6. It will check with the peak of the priority queue. The priority queue's peak is 3. This means there is a room, only one room, which is ending at 3. The minimum ending time of rooms is 3 and I need to start from 2. So this means we need to make another room for that. For 2 to 6 we need to make another room 2. But when we are creating a room 2, we need to again, this priority queue is saving all the ending times of the meetings of the rooms. So this 6 will be added in the priority queue, and it is min heap type. So at the peak 3 is here, 3 is at the peak. Now we have this in room 1, this is in room 2. Now the next meet is from 7 to 8. Again it will check with the start time and the peak of the priority queue. Here the start time is 7, which is greater than the ending time of the room 1. So we need the room which is free as soon as possible, that is the ending time is smaller. So we are using min heap, that's why we are using min heap for that. So it will give the room which is ending first. So the ending first room is at 3 and we need to start from 7. So we can schedule this 7 to 8 in room 3. So we will schedule it in room 3, 7 to 8. This is room 1 from 7 to 8. But we are scheduling the 7 to 8 meeting in the existing room. So this means we need to pop, we need to remove the peak value, which is the room 1's ending time, and we need to update the ending time of room 1, that is 8. So here we have two rooms, one is ending at 8, another one is ending at 6. And if we see in the priority queue, we have only two elements, one is 6, one is 8. 6 shows that ending time is 6 of the room 2. 8 shows that the ending time of room 1. This means we can get the number of rooms by the priority queue size. There are only two rooms and we have only two ending times. Now the next meet is from 8 to 10. Now this time at the peak, this time at the peak there is 6. Now it will check from 8 to 6, it will compare. Now here 6 is ending time and 8 is starting time. So this means this 8 to 10 can be scheduled in room 2. Now it will be scheduled in room 2. This scheduling in room 2, and because we are using existing room, so we need to pop the existing room's ending time, and we need to push the new ending time of that room, that is 10. Okay, now this is rescheduled in room 2. We have two rooms, one is ending at 8, another one is ending at 10. This time at peak, the 8 is at the peak. 8 is at the peak. Now 9 to 15, the next meet is 9 to 15. It will again check for the peak value of the priority queue. Here 8 is the peak value. So this means from 9 to 15 it can be scheduled in room 1 because the ending time is 8 and the starting time is 9. So when it will be end in room 1, after 1 hour it will be start from 9 to 15 in the room 1. So we will update 7 to 8 by 9 to 15. Now in room 1 the ending time is 15, so we need to update the value of room 1 by popping the value which is in the peak, that is we are removing the value and we are pushing the ending time of that room. Now this is in room 1. Now all the meetings are scheduled. And the answer will be, here we can see in the priority queue there are two rooms where one is ending at 10, another one is ending at 15. This means only two rooms are required, and the size of the priority queue will be the answer. At the end, the size of the priority queue will be answer. Now the steps are first step is to sort the input array according to the start time, so that we can get the structure of the meetings. Now second is we need to use priority queue of min heap type. And the third will be the conditions. If pq dot peak is greater than the next start meeting, this means we need another room. So we will push pq, that is we are adding pq dot add next meeting's ending time. Priority queue is adding the ending time. Else this means we have a room. So this means we need to update the next room, the existing room's ending time. So for that, first we need to remove the peak value, and then we will push that, then we will add the next meeting's ending time. This will be the condition. At the end, priority queue size will be the answer, where it will show the meeting's ending time. Here we have 10 and 15 as the two meeting rooms ending time. Now let's code this. Now first we need to sort the intervals array. So arrays dot sort according to intervals according to the start time, and here the start time is at 0th index. A0 is less than B0. This will sort the array according to the start time in ascending order. Now we need a priority queue of integer type to save the ending time of the intervals, ending time of the meetings. PQ is equal to new priority queue. Now we need to iterate from 0 till intervals dot size I plus plus. Now the condition is when PQ dot size is equal to 0. This means there is no rooms assigned. So first of all we need to assign a room. So we are adding the first meet's ending time. Ending time will be at I at 1. Else this means there are rooms. So if there are rooms, we need to check if PQ dot peak is greater than next start time, that is intervals I at 0. 0 is the starting time. If it is greater, this means we need to add a new we need a new room. So it will add the new room's ending time of the meeting. Else we need to pop the existing rooms. Here this will be remove existing rooms meeting, and now we will add the new meeting's ending time. Here we had popped the existing rooms meeting, and here we have added the new meeting's ending time, and in the end we need to return PQ dot size. So this is the code. Let's try to run this. Here it is giving error. Let's see what is the error. So here this should be the length, and let's try to run this again. So the argument mismatched in lambda expression. Boolean cannot be converted to int. So let's try to compare it. Instead of returning the values, let's try to compare it in integer dot compare a0 comma b0. Now let's try to run this again. So it is giving the output. Let's submit this. So all the test cases are also passed. So here we have sorted according to start time. Then we have used a priority queue of min heap type. This is the condition when there is no room. There is no room assigned to any meeting. This is for the first meet assigning room. This condition is for checking is there available or not, is there any existing room available or not. So here this condition is for new room. If the peak priority peak is greater than the next meeting starting, this means we need a new room. As this is for the existing room, and here we have updated the existing rooms ending time. So this is the code. Hope you understand the concept. We will see you in the next video. Thank you.